So when we transmit the data, there's actually, you can see that there's 16 bits that are transmitted. So we transmit 2 8-bit words, and the data, each bit is labeled here. There's an AB bit, a buffer bit, a GA bit, a shutdown bit, and then 76543210. That's our data that gets shifted out, and then these are X's, or don't care. Doesn't care what those are. From the data sheet, it has descriptions for all these bits. So the first bit is, it selects whether to write to the DAC A or to the DAC B register. So 1 is B and 0 is A. And the next bit decides if it's buffered or unbuffered output, and we're going to be using the buffered. And then there's a output gain selection, and 1 is times 1 and 2 is times 2. We're going to be using the times 1. And then the shutdown, we don't want it shut down. Everything we're doing, we want it on, so we want an active 1. And then the other bits, 11 through 0, are the data bits that we're transmitting. So let's go back and look at the chip now that we've seen the buff and the gain. So if we look at the chip, so the gain logic here, that bit will select between different gains on the op amp, and so that's what the gain bit does. And then this looks like the shutdown that shuts down the output. So you can disconnect the output, the op amp outputs, and then these switches right here, they bypass these buffers that buffer your input signal to your reference voltage. And sometimes if you have, we could probably use it either way because we have a really strong 3.3 volts that we're using. But sometimes when they use a reference for a DAC, they use really specialized reference voltage chips, and they have very low output current, and so they have these nice internal buffers that you could use to minimize the load on your reference voltage.